Hi, in this video I want to show you how to solve some basic acceleration problems in physics. Let's start with this one. An apple rolls at a speed of 1.8 meters per second until it reaches a downward slope and begins accelerating at 4.5 meters per second. How fast will it be moving after accelerating for 6.0 seconds? So I'm going to use my patent-pending guess method to solve for this missing information here. I'm going to start by drawing a picture because I always think a picture is helpful. So I've got my apple rolling down the hill. So this is the beginning, this is the end. Let's get a little detail in there, just to make sure we know what we're looking at. And it says that the initial speed right here at the beginning was 1.8 meters per second. So I'm going to label that on my picture. And then we don't know the final velocity. How fast it's going at the end here. Now, we also know it's been moving for 6 seconds. So I'm just going to start writing down some of my given information. So G stands for given information. I know that the initial velocity is 1.8 meters per second. And we're going to call that a positive velocity right now. It's moving to the right in my picture. The acceleration of the apple was given to us at 4.5 meters per second squared, or meters per second. And we also are given how much time it accelerates for, 6.0 seconds. So we don't know how long it was rolling on this flat part, before it hit the hill. All we're told is how much it moves as it starts to accelerate. So we're only paying attention to this time window right here as it's rolling down the hill and getting faster and faster and faster. So our unknown quantity here, we need to check back on the problem's wording at the end. It says how fast will it be moving? So how fast is going to be a velocity? Now, is this an average velocity? Is it an initial? Is it a final? And you have a clue there. It says after it's been accelerating. So that typically leads to a final velocity that we're looking for. But just think about the context of the picture here. We're looking for how fast it's moving at the end. So now we're ready to use an equation to solve for this problem. We want the final velocity. I'm going to use this equation that involves acceleration here. The final velocity is equal to the initial velocity plus the acceleration times the time. I'm ready to substitute in my numbers. So the final velocity is equal to, we had an initial velocity of 1.8 meters per second, plus we have an acceleration of 4.5 meters per second squared, multiplied by a time of 6.0 seconds. Okay, so still got plenty of room there. So multiplying this out, we have I'm going to keep this the same over here, 27 meters per second of additional speed gained here, but we're going to add that to our original 1.8 meters per second. That'll give us 28.8 meters per second for our final velocity. Let's make sure that we're accurately keeping track of our precision here. We're being honest about how precise our measurement is. And we have no decimal places here, so this is going to round up to 29 meters per second for our final speed. So it's sped up quite a bit. Let's look at one more while we're here. Let's say that we have a lizard that moves at a constant speed of 1.44 meters per second for 7.0 seconds. So I'm going to draw a picture here again. And here's my very realistic lizard. Okay, and this lizard is moving, it said, at a constant speed of 1.44 meters per second. Notice how I always draw my pictures, if I can, so that objects are moving to the right because the right is positive, so I want to keep that consistent. It says it moves for 7 seconds. Now, when I start to write down my given information here, I'm a little confused because I know it's 7 seconds, right? That's how much time we have. That's the easy one. But then I have a velocity measurement of 1.44 meters per second. Is this my starting velocity or is it my ending velocity? it says it moves at a constant speed. So it appears it's just my average velocity. It's just how fast it's moving. And so because of that, we don't have a change in the velocity here. This essentially is both our final and initial velocity. So if we were to, put in, and we just write all this out here, the acceleration is what we're looking for. If we were to put this into an equation where acceleration equals the final velocity minus the initial velocity over time, then you'll see if we just have the same velocity at the beginning and the end, then when we do our substitution step, they just cancel each other out, because 1.44 minus 1.44 is 0 over 7.0 seconds, but that's just going to be 0. So what's our acceleration? What's the lizard's acceleration here? It's just 0. And we know that before we even did this problem. I could tell that it was going to be 0 because it said constant speed. If something is moving at a constant speed, that means there is no acceleration. It's not accelerating. So watch out for that when you see problems that use constant speed as a description of the movement, because that tells you right away that there is no acceleration. So watch out for those trick questions. So that's all I've got for you in this video. Remember, everything you have is a gift.